Okay, welcome everybody to this tech classroom. In this session, we are going to talk about the Oracle NoSQL Database Cloud Service, which we just released a few weeks ago as a native Gen 2 OCI service. And we'll talk about the cloud service. But more importantly, for many folks out there that don't know what Oracle NoSQL Database is, we'll give you a background overview. We'll talk a little bit about why folks would choose to run certain workloads on a NoSQL database and where Oracle NoSQL Database really shines. We'll talk about the NoSQL Database Cloud Service. What is it? How does it work? And then we'll demo that cloud service. It's now exposed directly in the Cloud Console. And then finally, we'll show you how easy it is by writing our first application live. Of course, if you're a developer, you know that first application is always HelloWorld. Okay, so what is Oracle NoSQL Database? So we've been working on this database for about 8 or 9 years now. And at the core, it's a distributed shared nothing key value data store that has really been built from the ground up for high availability. So the best way to understand it is to really look at this diagram from the bottom up. And if you see the bottom there, we have these things called fault containment zones. So in this distributed database, everything is wrapped in what is called a fault containment zone. So at the very lowest level, there is the persistent storage device, whether it's a spinning disk or a solid state SSD device or high performance NVMe storage. These are all wrapped in fault containment zones so that if any one of them fails, we have redundant copies. If you go up the stack, there's this concept called the shard, and everything in the database is automatically sharded. Each shard has a dynamically elected leader node, and this is how we actually perform ACID transactions. So all writes are routed to that leader node. All requests for consistent reads are routed to that leader node. And so it is shard local ACID from the perspective of the typical transaction ACID model. And then finally, this all scales out linearly. If you run out of throughput, you can just wire up a new machine or a new rack, add it to this cluster, and a new shard will appear, and we will actually rebalance the store, the data store, by moving data around to take up that new capacity. And there's no cluster-wide gossip protocol, which some NoSQL databases use to come to a consensus in state. So it is really designed for scale out, linear scale. Okay, so a bit more about what we've focused on with this NoSQL database: flexibility, simplicity, and performance. And those are really the three key things that we focus on. So flexibility is probably number one. We think we're probably the most flexible NoSQL data store out there today. On the modeling side, you have your choice of key value, fixed schema table, ad hoc JSON. We also have a property graph package that runs on top of us. On the licensing side, again, really flexible. There's an open source community edition. There's an enterprise edition. We ship on a tuned big data appliance that is installed and pre-tuned for NoSQL database as well as Hadoop. And then we have the fully managed cloud service, which I'll talk about today. And then on the deployment side, you can connect to the fully managed cloud service. And really the paradigm there is you just pull down the driver you want to use for the language you would like to use in terms of programming language. You connect to the cloud service and create a table and start writing and reading data. And now you are not tied to our cloud. You can run the same exact NoSQL database code in any data center of your choosing. And again, just connect to it, create a table, and start writing and reading data. So we're not going to tie you into the platform. We give you that flexibility. And then, as you'll see, we think it's super, super easy to get started. I'm going to show you how to write your first Hello World code, probably in less than 15 minutes, maybe 10 or even 5. And then on the performance side, we really focus on predictable response times for simple queries. So we don't try to do very, very complicated SQL. It's not really arbitrarily complex. You don't do big joins or big roll-up operators. It's really focused on simple access, giving you very, very predictable single-digit millisecond latencies. And of course, along with that, you really want the throughput piece. And I'm going to show you exactly why that becomes important a little bit later. So on the flexibility of licensing, as I said before, we have a number of different options. There's a community edition. It ships as Apache to open source. You can use it. You can redistribute it. You can do whatever you want. You just can't get mission critical support. If you do have questions, there's an active forum, and you can get your questions answered there. Then there is the Enterprise Edition. It's a standard core-based licensing from Oracle. The nice thing there is that if you do have any unused RDBMS core licenses that are basically on the shelf, you can use those without paying any extra fee to Oracle and get a fully licensed, supported, mission-critical supported edition of Oracle NoSQL. Again, no extra fee. And then there's a bunch of value-added features that are in the Enterprise Edition that don't come with the Community Edition. There's extra security. There's a streaming change data capture piece of functionality. There's integration with Big Data SQL and multiple other systems, Hive via storage handler. There is integration on the management side with Oracle Enterprise Manager. And then there's this thing called multi-region tables, which to do active disaster recovery across multiple geographically distributed regions, and we will keep your table in sync bidirectionally across these multiple regions. And then finally, there's this serverless fully managed cloud piece, which is what I'm going to talk about in a bit. And the license model there is you just create an Oracle Cloud account. You purchase a number of read units and write units and gigabytes of storage. And you all do this when you create the table. Again, you'll see this in a bit. And you just connect and go. Okay, a little bit more about the model for Oracle NoSQL Database. All of these distributed databases live within something called the CAP theorem. And the CAP theorem really defines three pieces here. There's the consistency piece, the availability piece, and the tolerance to partition failure. And what they're really talking about is if a part of the network goes away, what happens? And so in the case of Oracle NoSQL Database, we lean more towards the consistency piece. And we trade off for that a little bit of the availability piece, and we hedge our bets. And how do we do this? And why do we do this? So when we looked originally at designing this product, we noticed that many applications are read heavy. And if you think about the applications you interact with every day, you can easily realize that most of your activity in the applications you use in your daily work, you are typically 90 to 95% read with 10 to 5% write. So we wanted to make consistent read operations very, very cheap. And we do that by just routing the read to the leader node in every shard. And then, of course, nothing is free, so we had to trade off a bit for the availability piece. And what we mean there is that if the leader node should fail at any time, we hold what's called a Paxos election, which is a consensus algorithm that will eventually elect a leader node, but of course there is a little bit of increased latency for write operations as this leader election is happening. But again, it's all automatic. The only effect here is it will lead to a little bit of an increase on the latency for a write operation. And then, having said that, we try to hedge our bets, right? We don't have a single leader node. We have a leader node per shard. So if a leader node in a shard should happen to fail and we are electing another leader node in that shard, it doesn't affect the rest of the operating system, right? So everything is operating as it is. We just have one shard out there that is doing an election and exhibiting a little bit of increased latency during that election. Okay, a little bit about ACID semantics. So everybody writing database applications has all heard about ACID, right? A is for atomicity, C is for consistency, I is for isolation, D is for durability. And you are either in this world of ACID or you're not, or in our case, right? One of the things we realized was people really would love to have some flexibility. And they would love to be able to trade off latency for things like consistency when we're talking about reads. So on the top here, what you're looking at are the different options that we offer for read consistency. So on the right-hand side, that is the most consistent. And if you tell us you'd like to do a read and make it absolutely consistent, as I said before, we will just route that read to the leader node. It's very cheap. You can tell us, I'd like to do a read and give us a maximum bound for how out of date that data can be from the leader node. That's called maximum lag. You can also say, hey, I want to bound the staleness of this read. I have written this data at a certain version number, and I'm going to pass in that version for when I wrote it, and I'd like to get at least that version or greater. And that's called bounded staleness. And then finally, on the lower end, you can say, look, I'm really, really concerned about latency. I need to have this operation complete as fast as possible. And I don't care how recent the data is. And there are a lot of use cases like this. And we'll talk about a few. And then on the right side, you can say how durable you want that write to be. And there are two flavors of this. There are how durable you want it to be down the stack of hardware all the way to persistent storage. So you can say just write it to memory, file system buffer cache, or flush it all the way down to persistent storage. And you can tell us how many acknowledgements you would like to receive from the replicas in the shard to consider this transaction successful. And again, you can say, I need all replicas to receive the write. I need just a majority of them, or I'm really, really concerned about the latency, and I'll take my chances and just write it to the leader node and then return immediately. Okay, so on the data modeling side, back to our theme of flexibility. We offer, again, fixed schema, schema-less, and a combination of both. And on the left-hand side, you're looking at the fixed schema world where we've created a table with some scalar data types along first name, last name of string. And we've indicated that primary key here is going to be the ID, and we're also going to use that for the shard key, right? So that little shard keyword says, hey, use this ID for the shard key and just automatically distribute this across all the shards based on ID. We also offer support natively for arrays, and you just declare a column of an array data type. You can access by index. You can do containment queries by saying, you know, give me all of the records in this table who have an array entry greater than a certain value or equaling a certain string. And then finally, you can do fixed records, as you see on the bottom, really a hierarchical set of data that describes the attribute and data type of each element in that record. And then on the right-hand side is purely schema-less JSON. So this table here, we've, again, created an ID as a long, and then we've just said, hey, we've got one column, it's JSON, we're done. And again, we said we're going to shard on that ID, and it's also the primary key. And then the content of this table will be right, an ID for the record. And then, as we're seeing here, every record in the table will contain the names of the attributes as well as their values, right? So very, very flexible, really nice, gives you the ability to just, modify things on the fly, issue SQL to access this stuff, and slice and dice any way you want. Okay, now on the how do you get access to this stuff? There are two ways to access data in our system. We try to focus on the development experience and making it really nice. On the API side, you could just call get or put, or scan APIs if you're dealing with key value pairs, and you can even do this for tables if you like. There are version-based test and set operations for the write. They're called put, of course. And you could do things, like put if absent, put if present, and these will take in the version number, test to see if a version of a record either exists, or you can call put if version to say, hey, only write this record if the version of it hasn't changed. And then you can send in your consistency settings for your get operation, as we saw before, decide how consistent you want the data to be. There are APIs for deleting a single record or deleting multiple records for the multi-delete. Again, as we saw before, this will be a transactional operation only at the shard level. There are no distributed transactions in this database. And then finally, you can write multiple records. We have a batch write API, again, ACID at the shard level. And then if you're using JSON, it's probably more convenient to be able to have a declarative query language because you don't always know what's in that JSON record. And so we have a very rich SQL dialect for accessing JSON. So you can do more complex filtering expressions, support for ands and ors, those are conjunctions and disjunctions, chaining those filter expressions. Basically everything you can do in SQL in terms of the expressiveness of slicing and dicing through data, you can do in our SQL dialect, including filtering through arrays and projecting out fragments of a JSON document. And then we have complete interoperability between the schema-less JSON world and the fixed schema world. And this is really because we can natively handle the fixed record data type, as we saw before, as well as the array data type. And so it's really the exact same SQL that operates over those fixed data types as well as schema-less JSON. Okay, so why would folks use a NoSQL database, and more specifically Oracle NoSQL? Some of the more interesting use cases that we see out there that are super common. The first is, in the last several years, probably the last 10 years, we've seen that people developing applications are really creating sort of applications customized to the individual. So if you think about some of the retail or online shopping user experiences that you're familiar with, you'll immediately realize that when you go to a site, the page you land on, if you've been there before, is immediately customized with product recommendations, things you may be interested in, movies that you may be interested in based on your past behavior. And these things render very, very predictably and very, very fast. So typically, right, the idea here is to render the page in 1 second or less, predictably, no matter how many millions of users like you are landing on the site. And the way that these folks are doing this is they are taking these product recommendations or fragments of data that they're using to render that page customized for your cookie ID if you're coming in through a browser, or your IDFA or Android ID from the device. And they're doing these very fast lookups in a NoSQL database and pulling these fragments of data out to render the different parts of the page for customization specifically for you. And so to do this, what we've been told by some of these large retailers is that it can be anywhere between 200 to 300 database operations to really render a very rich experience that's customized to the individual. And so if you just do the arithmetic, you'll realize that the database operations have to complete in a few milliseconds if you have a prayer of being able to predictably render that page in a second or two. And then the other use case we see a lot out there is for collecting like sensor data from either manufacturing devices or on the factory floor. Data centers, right? Folks that are actually collecting telemetry to run a data center, or in one example for Oracle NoSQL, very large plane manufacturer using Oracle NoSQL to collect the sensor data from all of the test flights to be able to validate an aircraft before that aircraft goes into production. Huge amounts of data, millions of events per second. And you need to be able to have indexed access to that data to be able to aggregate some of these events on a more coarse-grained level, to be able to analyze the data and build predictive models for component failure. So we see this quite a bit. And then, of course, there are people that are doing real-time fraud detection, right? You swipe your card, and within the transaction path of that operation, right, there's a human being on one end. You would like to be able to not introduce any unneeded latency within the path of that card swipe, but at the same time, you'd like to be able to read a model, based on the credit card ID out of NoSQL database, score that model for the probability of fraud. And then do the right thing on the back end, right? If it's not fraud, you'd like to update your set of historical transactions with this latest one. If it is fraud, of course, you're gonna deny it and probably put the card on hold. And then we see a lot of folks doing things like caching data from relational databases in JSON format, right? This we see quite a bit where folks would like to, take the data that's in the operational data store today and then expose that data for consumers on the front end. So a great example of this is now with many of the airlines, you can actually track your bags in real time as your bag moves along the flight route with you. And this data is stored in the operational database on the back end. You'd really not like to add all of that consumer-based, query and read operation to the back-end operational data store. What you'd really like to do is offload all of those reads from devices to the NoSQL database and have access to that data in JSON format to be able to, easily write a front-end application and get that data into the hands of the consumer. So those are just some of the use cases that we frequently see. Okay, so now on to the fully managed cloud service, right? The thing we're really going to demo, we're going to show you how to write some code against this thing. So the NoSQL Database Cloud Service works on this concept of provisioned reads and writes per second and gigabytes of storage, and all at table creation time. And so typically when you're going to write an application, the typical exercise some folks do is they'll go through and they'll size and figure out how much hardware they need to buy for the database piece of their application based on how much throughput they think they'll have, and of course they'll give themselves some headroom in case their application gets really successful. And in this case, instead of actually going through and buying hardware, you just figure out how many reads and writes per second you're going to need, how much storage you're going to need, and then when you create your table, as you see in this code here, you just give us a table limits object, and you tell us the read units, write units, and storage that you need. And this stuff is dynamic. So If in fact you get a rate limiting exception at runtime, you could just call the set table limits again and increase your limits. If you find that you're completely idle and you don't want to pay us for those table limits while the application is idle, you could just lower those things down. And so a little bit about what a unit is. So a read unit is the ability to read up to 1K of data per second, loosely consistent. If you would like an absolutely consistent read, it will cost 2 read units. A write unit is similar. It's the ability to durably write up to 1K of data per second. And then, of course, storage is just in gigabytes. Okay, where is this thing live? So as I speak today, we are currently live in 6 regions. So west coast of the US in Phoenix, east coast of the US in Ashburn, Virginia. We are live in Frankfurt, Germany, and Zurich, Switzerland in Europe. We're also live today in India, in Mumbai, and Sydney, Australia. And then we'll be rolling out another 5 regions this month in April, followed by the remainder of the 19 regions. We should be live in all 19 regions by the 2nd week of July. Okay, so now we are going to demo the cloud service. Okay, so I'm at the Oracle OCI, so I'm actually going to go here and I'm going to give my tenant ID, or actually the name of my tenancy, and I'm going to log in. So if you notice, we are currently pointing to Zurich, so I am actually going to change, and since I'm in the US, I'm going to set my region to be no, I think we are. Yeah, I'm going to set my region to be US East. And so the first thing I'm going to do is, for the purpose of this demo, I'm going to go ahead and create what's called a compartment. So I'm going to go to the identity piece here, and I'm going to create a new compartment because I would like to just store off this table that I'm going to create for this demo just in a separate compartment so I know where it is. So I have my own compartment here called Dave. And underneath that compartment, I'm going to create a new one called tech_classroom. Classroom demo. Okay, so we see now that tech_classroom compartment has been created. So now I'm going to go over back to my menu, and I'm going to go to the NoSQL Database section. And now the new compartment that I created, tech_classroom, is right there, right? And I'm going to create my first table here, just using the UI. Now, of course, if you're developing an application in the real world, you probably don't want to use the UI. You probably want the create table with all the columns in the table encapsulated in your code, but I'm just going to do it to demo what you can do with the UI. So I'm creating 2 columns. The primary key column I've set as an ID, and that's of data type long. We'll set it as a shard key. And then we will just create another column called content, and we'll just say, hey, that's some JSON content. And again, here are my read units, my write units. I'm just going to say we want 100 of each, and I want 25 gigabytes of storage, and I'm going to create my table. And so if you see we are in the creating state, it takes typically anywhere between 3 to 10 seconds, depending on how long it takes for that table to make its way through the entire cluster and through cloud identity. It has to be registered, of course, as an identity object. So now there's my table. And now what I'm going to do is, before we get to the rest of the UI, I'm actually now going to show you how to write some code against this table. So we're going to write our first application at this point. Okay, so to begin writing your first application, right, what do you have to do there? Well, basically, right, like any other application, you kind of want to get a feel for the APIs, but before you do that, you really need to look at the docs and find out, well, okay, how do I get started? How do I actually create a connection? And if you see here, I am looking at the NoSQL Database cloud service documentation, and there's a little section here called connecting to the service, right? And the first thing it tells me to do is go ahead and download and install the SDK or the API. And if I click that link, I get right here to the cloud service homepage. And if I go to the developer piece, I have a few things that I can download. I'm going to do this in Java, but there are Python, Node, and we also have a Golang SDK that should show up here in the next couple of days. But for the purpose of this demo, I'm going to use Java. I've already downloaded this Java SDK, so we don't have to sit here and wait for the package to download. But that's step number one. Okay, so now we've installed that. So now we actually have to figure out how to get authenticated to this service, right? So we need to figure out, hey, where do I find the necessary credentials to actually get connected? And if you look at this table here, right, these are the credentials that we'll actually have to go and find to be able to get authenticated. So we need our tenancy ID and our user OSID, right? So we'll click that link and figure out, well, where do we find this information, right? So what does this say? So we'll go to the administration tools and into the tenancy details piece here to find our tenancy OSID. So we'll go here and we'll go to the tenancy details, right, to try to find that first piece of information. Okay, and that's taking a minute to render. And then there we go. Okay, so there's the tenancy OSID. So I'm going to copy that into the clipboard. And what I've done here is I've actually set up a HelloWorld class. And just temporarily, I'm going to copy that OSID over there, right? Okay, what was the next thing we needed? Okay, the next thing we need is the user OSID, okay? So let's see, where do we go find that, right? Okay, the user's OSID, we will open up the profile in the user settings and go look for the user OSID there. So let's see, the profile, user settings, should be able to find the user OSID here. And there's my user OSID. I'm going to copy that to the clipboard. We're going to save that again right here. Okay. And then, sorry, here we go. And then we need, of course, we need an API signing key. I've already registered an API signing key so that we can get us past that step here. That's really just takes a second to generate a key and just upload the key. And then the fingerprint for the OCI signing key, you can get that a couple of different ways, but to see that, so let's go back to here. You can see that I've uploaded a key, and there is the fingerprint for my key. So I'll just cut that and paste it there, and then, okay, so we've basically got everything. And then, of course, the passphrase for the signing key is something that is private to me. When I created my my key pair, I created a passphrase for it, and of course, I'm not going to find that anywhere but in my own environment where I've safely stored it away. Okay, so I think we've got all the information we need to get connected now, and so we'll look at how do we do that, right? There's the Java doc for the NoSQL database driver. And you can see this NoSQL handle, right, is kind of the handle to the database, right? And you'll see that when we look at this, right, there's this create handle call, right? So we'll go ahead and look at that to look at how we create that thing, right? And you'll see that there's this config, right? So we need to somehow create this config. And so basically, this config takes an authorization provider. Okay, so that's good. We need to figure out how to get authorized, right? So there's a bunch of information that we just saw that we're going to have to actually give to this authorization provider. So we have a blog that shows you already written code to get connected to the database. And so we're going to go cut and paste this code since we already have it. So we have the signature provider, and I'll take you through this. But we're going to put it into our IDE here. We're going to give it a method name. Okay. Okay, so we got a few things here. We're going to actually import this class. Okay, we're going to import this class. And finally, we're going to import this class. And finally, we're going to import this class. Okay, this one as well. So now here we've got our data, and basically this is our tenancy OSID, as you noticed before. We're just going to plug that in here to this signature provider. This is our user OSID, if you remember. We're going to plug that in here, right? This is the fingerprint of our key. We're going to plug that in here. I've got my key sitting in this directory right now. We're going to import the file class, right? And then I'm going to need to put in my passphrase, right? I'm going to need to go find my passphrase. Okay. And again, this is something that is stored privately on my machine. And then in this piece of code down here, you will notice that we are creating a handle to the NoSQL database. We're going to return it. And we're saying, hey, we'd like to connect to the Ashburn region. And also what I'm going to do is if you noticed before, right, I created a compartment for my table, right? And I put it in my Dave compartment, and I called it Tech Classroom. We're going to spell that correctly. Okay. So now what I'm going to do is I'm going to actually try to write a record into that thing, right? So I'm going to take my code that I have already have. If you look at the Java doc, you'll see it's super simple to just write your first record. I'll take you through this. All we're doing is we've written a method here to take in the handle that we created up here, the ID for that record, and just a string of JSON. And we've created a map value using the map value class in the NoSQL Database API. And we've said that the content we're going to create by putting from a JSON string, right, the string that we have passed in, and we're going to give it some JSON options, and we're going to call that the content value, and then we just we create a put request with the value, and we set the name of the table, and we call the handle to actually put the record. So now I'm just going to actually put a main here. We're gonna run this code, and we're gonna show you how it works. Okay, so since we've already created the table, we're not going to show you how to do that. We haven't written the record yet, so okay. We're going to go fix this. Don't need to. Right, we're good. Okay, so now we've got our code that actually is just writing a single record. We're going to go ahead and compile this, and we're going to try to run it. And if you see here, we're just taking the handle. We are passing to our method to write a record the ID of 1 and a little JSON hello world string. So we've actually compiled the code. Now we're just going to go ahead and run it. And if all is successful, we'll see this little message that we have actually written a record to the NoSQL database. Whoop, and we haven't. So the tech classroom is not a valid compartment, so let's go see what we did wrong there. We'll go back, and okay, so let's go back and see where we are. Let's go see where we actually created that. Oh, it's actually in developers, Dave. So that's where we made our mistake, right? So let's go ahead and fix that. Okay, hopefully that will fix this for us. Let's try to run that code again. And hopefully we'll see a message. No, we have another issue here. Where are we? Okay, we're going to try a different compartment. We're just going to use compartment Dave. Let's go back to our code. Let's see if we get this correct. Okay, our table is there. And we're going to try running that. Now remember, so one of the things to note here is that we're actually running this on my laptop, and it's connecting over about a 65 to 80 millisecond speed of light to the east coast of the US. I am on the west coast of the US. Okay, so we'll have to go back and figure out what happened with our other compartment, but we have now written a record to the database. So we're going to go back and let's just quickly take a look at HelloWorld. We should actually see the record. So we can go here and we can look at the table rows. We could click that run query, and we can see indeed our HelloWorld is there. And then we could just basically say, okay, well, let me write another record just to show you. Let me write HelloWorld number 2. Let's rebuild. We're going to do it again. Again, remember, we are connecting over a WAN to actually get to the database. Of course, we would never recommend that you do that for a low latency application. You want to run close to the data center where your application is running. Now we should see 2 records in the store, and indeed, we do have 2 records in the store. So that was a quick example of how to actually write data to NoSQL. We could show you the read code as well, but since we're running out of time, I will open this up for questions now.
Hi all. So we've reached the Q&A section for live questions. So we'll just open it up for folks that have questions. So we got a comment from somebody that says the table name was wrong in the example. I'll have to go back and look at that. I think you may be referring to the compartment name. Is that correct? Okay. Okay, so another question is regarding which Java libraries do we need in order to run from a local laptop. So when you download the NoSQL SDK, Java SDK, that's all you need. So in that SDK, I think is 4 jar file libraries. One is the NoSQL driver itself, and then the other 3 are the libraries that are needed for connectivity to NoSQL. So again, you just download it, unwrap the tarball if you're downloading like a tar.gz, or just unzip the zip file, and all your libraries will be in the live directory. And again, I think it's just 4 that you need. The console URL is the next question, and so if you actually just go to, I think it's cloud.oracle.com, and of course you need a cloud account to access that console. As soon as you have a cloud account, you just go to the Oracle Cloud console, and the upper left hamburger icon menu, if you pull that down, you'll see NoSQL underneath the database section. Yeah, so the session is available. You know, I don't exactly know where the session will be posted. I don't know, Marcy,
I can answer that, Dave. Yeah, just wanted to mention that it is recorded, and you can access this session on demand after this live session is complete, using the same URL you used to access this live event.
Thanks, Marcy. The next question is Oh, go ahead.
Nope, that was it.
Okay. The next question is how can we measure performance? That's a really good question. And for anybody that wants to get a sense for our predictable performance for these read and write operations, I would encourage you to do this. We've actually written an example application that does just that. And it's pretty simple. You basically just, you can take a timestamp before you make the database read or write call, the put request or the get request, and then take a timestamp after, compute the difference, and then you'll see that if you collect a bunch of samples there, it'll be really plainly evident that the latency of those operations, typically for reads, it's roughly 2 milliseconds. And again, if you're going to do the measurement, you probably want to run your application in the same region local data center as the NoSQL region you're connecting to. Otherwise, you're going to encounter latency over the internet, and there's a bunch of undeterministic stuff that can happen there. So if you are going to measure it, I would basically spin up a VM in the region you're going to do the measurement, and then look at the numbers. And for reads, you'll see probably 1 to 2 milliseconds on average, and then for writes, you'll see anywhere between 2 and 4 milliseconds. And even better than average, if you're familiar with performance measurements at the 95th percentile, you'll see these numbers very consistently. So we feel really good about those numbers. Okay, the next question is about C#. We are working on a C# driver now. We hope to have that available probably sometime in the summer, maybe towards the later part of the summer. So that's coming soon. Let's see. So the next question is Oracle NoSQL available for the always free Oracle Cloud account? So we are working on an always free tier for Oracle NoSQL. And again, the time frame there is similar to the C# time frame. We think it'll be available either late summer or early fall. Right now, you can use, there's a $300 free credit that you get for the Oracle Cloud. Those free credits can be used against Oracle NoSQL. The only caveat there is I think they time out after 30 days, and the always free tier will be perpetual, right? So you'll get 50 read units, 50 write units, and 50 gigabytes of storage, and that will not time out. But again, that won't be available for several months. So the next question is about using Visual Studio. Currently, we don't have a plugin yet for Visual Studio. The only two plugins we have as we speak now are for Eclipse and IntelliJ. The Visual Studio plugin likely won't be available I guess at the best, it would be end of this calendar year. Likely, it will be early 2021 for the Visual Studio plugin. Okay, the next question is does Oracle NoSQL support ORDS for REST to be able to plug it into PaaS cloud services? So currently, we do not currently support ORDS for the cloud service. We do support a REST interface. It is not, though, ORDS right now. That's one thing we're looking at. So just to reiterate, currently, as we speak, the languages that we do support on the API side of the house are JavaScript via a Node.js driver, Python, Java, Go, and we do have a REST interface. And indeed, The cloud UI that you saw in that demo is using the REST interface. So yes, it can be used from something like C#, but it is not it's not as capable as a full-blown driver. So the next question, is there support service available in case of development need? Not quite sure exactly what that means. How can we get more content for the same? Is that for, I can't tell if this question is about Visual Studio or not. So maybe, I think that came from Sanchit. If you could give me more context on that question, I'd be able to answer it. Okay, the next question is how do we know about the API features? So a couple of things there. If you do a Google search on Oracle NoSQL Database Cloud API, if you're just like wanting to know what's in the API, that will get you to hosted Java doc that will give you the details on the API. If you want to know what features there are in the cloud, you can do a search on, just do a Google search on Oracle NoSQL Database Cloud documentation, and the docs will give you a good overview of what features there are with NoSQL Database in the cloud. And of course, there's a bunch of information on our Oracle.com homepage. And if you just do a Google search on Oracle NoSQL Database, you'll get to the NoSQL homepage at Oracle.com, and it has a bunch of information on what features are supported. Okay, so the next question is, let's see, can we use NoSQL in OAC? Okay, Oracle Analytics Cloud support. We are currently in the process of integrating NoSQL with a bunch of other different cloud services. OAC is one, and unfortunately I don't have a date yet for you, but currently, right, we're just currently in the development process for integrating with things like Oracle Analytics Cloud. Not there yet. Next question is any roadmap support for Apex? It's an interesting question. So currently, we don't have any. I'd be interested to dig down on that further. Apex is currently, designed really for a more relational style application, much less for the NoSQL world. But currently, the answer is we don't have that on the roadmap. But it would be interesting to drill down on that one with folks to see if they really find that a compelling, if there's compelling use cases for that. Okay, the next question again is about OAC, not yet coming. And then I guess so, Sanchit, you meant, do we need some support on the Oracle NoSQL development? Does Oracle TAR? Maybe we could take that one offline. I'm still not clear what you mean. Support on the development of Oracle NoSQL. I'm not sure what you mean there.
Hey, Dave, we're coming to the top of the hour, so maybe let's just take one more.
Okay. Okay, the next, I think, hey, is there any limit on the JSON message size being written? Yeah, so actually, if you want to look at the limits, I think 500 meg, if I'm not mistaken, is the limit for a record size. Anyway, so just do a Google search again on Oracle NoSQL Database Cloud limits. You'll see a whole bunch of limits that are defined there. It'll give you a good overview of all of the limits we currently have for tables.
Great. Thanks, Dave. This is very useful. Thank you for such a comprehensive presentation. I just wanted to, again, let you know that this is being recorded and you can go back in and review the on-demand version of this webcast. There is going to be a survey that will be presented to you, so we'd appreciate any feedback that you have. We want to make these more useful, and wanted to thank all of you for attending today. We hope you have a great day, and if you have additional questions, feel free to email Dave directly. His email is on your console there, so feel free to do that, and thank you, Dave. Thank you, everyone, for attending. Dave, is there anything else you want to add?
No, I just want to thank folks for for watching and for watching our bugs in my application code. So that was thanks for putting up with that, and thanks for your great questions. And again, email me directly. We'd be happy to answer those questions directly to you.
Great. Thanks, everyone.
Thank you.